Good morning, students. In continuation to the last class, I am going to talk about the transistor operation. In the last class, we have studied the transistor operation when the emitter base junction is in forward bias and the collector base junction is in reverse bias. When the emitter base junction is forward bias and the collector base junction is reverse bias, then that mode of operation, we know that it is active region. When the emitter base junction is a reverse bias and the collector base junction is in a forward bias, and that is about it is a cutoff region. When both the junctions are in the forward bias, that is called saturation region. So in the last class we have studied the collector current equation. The collector current equation, we have that IC is equals to alpha DC IE plus ICBO. This ICBO is nothing but it is a reverse saturation current when the collector base junction is connected is in a reverse bias. In the reverse bias, we know that the PN junction diode conducts a very small amount of current. That current is named as reverse saturation current. Here, the collector base junction is connected is in reverse bias, so that it constitutes the current is called a reverse saturation current, and it is denoted with ICBO. Here IC is equals to alpha DC into IE plus ICO, and IC is nothing but it is the collector current and it is the output current. And by applying the Kirchhoff current law for the transistor, that is summation of entering current is equals to summation of leaving current. Summation of entering current, here the entering current is only the emitter current and the leaving currents are the base current and the collector current, so that we can write IE is equals to IC plus IE, IC plus IB. If IB is constant, if the IB is very small and it will be is in microamps, so that we can neglect that one, so that from that case, if ICBO can be neglected, then alpha DC is equals to IC by IE. IC and IE both will have the same amount of current, so that we can have alpha DC is almost near to 1. Alpha DC is equals to IC by IE, because IC is approximately equals to IE, so that we can have alpha DC is equals to 1. Alpha DC is nothing but it is a current gain. Current gain when the transistor is connected in common base configuration. And the same transistor is connected in common emitter configuration, that current gain can be denoted with beta DC. If the same transistor is connected in common collector configuration, then that current gain is named as alpha gamma DC. So that alpha is a current gain in common base configuration, beta is a current gain is in common emitter configuration, and gamma is a current gain in the common collector configuration. So that as we know that the collector current is given by IC is equals to alpha DC IE plus ICBO. Based on this equation, we are going to study all the possible currents through the transistor. Then we know that IC is equals to alpha DC IE plus ICBO. Then by having the Kirchhoff current law, we can have the equation, that is IE is equals to IC plus IB, so that I can substitute here IE is equals to IC plus IB, so that I can write IC is equals to alpha DC, IE is nothing but IC plus IB plus ICBO, so that I can write this is IC is equals to alpha into IC plus alpha into IB plus ICBO, so that I can take the IC term left side, so that I can have 1 minus alpha DC into IC is equals to alpha DC into IB plus ICBO, so that from that collector current IC is equals to I can write alpha DC by 1 minus alpha DC into IB plus ICBO by 1 minus alpha DC. This is the fourth equation, that is IC is equals to alpha by 1 minus alpha is named as alpha this alpha by 1 minus alpha is nothing but beta, and 1 by 1 minus alpha into IC, 1 minus alpha into ICBO, we can write that is in common emitter configuration reverse saturation current, that is ICEO. So that we can write here beta DC is equals to alpha by 1 minus alpha DC, and ICBO is equals to ICBO by 1 minus alpha DC, or you can write in another form, that is beta plus 1 into ICBO, and likewise we can go to the various forms of the collector current of a common base configuration. We know that since the alpha DC value is almost near to 1 only, and it is 0.99, and it is almost equals to 1, and approximation can be made by, if you go with the approximation of alpha DC is equals to 1, means I can directly write this equation as this ICBO is very small, it can be negligible, so that IC is equals to alpha DC into I only, because by neglecting what? By neglecting the ICBO, that is the reverse saturation current, we can have IC is equals to beta DC into IB. That means what? From the fourth equation, what we can write here, fourth equation, ICEO, that means what? It is the reverse saturation current when the collector emitter junction is connected in the reverse bias, so that it is very small amount of current, reverse saturation current is in microamps, so that we can neglect this one, so that IC is equals to beta into IB, where beta is equals to IC by IB. Beta is nothing but it is a common emitter current gain, always current gain is nothing but output current by input current, that is nothing but it is a current gain. Values of alpha and beta vary from the transistor to transistor. Both alpha and beta are sensitive to the temperature changes. That means what? If the temperature changes, the value of alpha and as well as value of beta can also be changes, so that these alpha and beta, these are the current gains, that is in the common base configuration and common emitter configuration, can be changed with respect to the temperature, and that affects by the aging factor also, as the age of the transistor is more than the alpha and beta values also changes with respect to the age, so that these two are the factor which can vary the values of alpha and beta. Alpha is nothing but it is a current gain in the common base configuration. Beta is nothing but it is a current gain in common emitter configuration, whereas gamma is the current gain is in a common collector configuration. So that we have the three configurations from the BJT. BJT is nothing but bipolar junction transistor. It has the three terminals: emitter, base and collector. If emitter made as common for the collector and base, that is called common emitter configuration. If the base is made common for the emitter and collector, that is called common base configuration. If the collector made as common for emitter and the base, then that is named as common collector configuration. In these three configurations, the transistor can provide the various values of current gains. The current gain is always defined output current by the input current, so that there are no units for the current gain, because the numerator is in current and the denominator is also is in current, so that amps get cancelled, so that there are no units for the gain, so that it is a dimensionless. Then we are going to talk about the another important thing in the transistor, that is called transistor configuration. Just now I have explained the transistor has the three terminals: emitter, base and collector, and any transistor can be composed of the two-port network. That means what? In a two-port network, to give the input signal, it requires to have the two terminals, and to provide the output from the transistor, and the transistor required to have the two more terminals. That means what? In total of the 4 terminals, it requires 2 for accepting the input and 2 for the delivering the output. But but basically the transistor having the 3 terminals only. That means what? Emitter, base and collector. To provide the proper amplification, the transistor required to have the 2 terminals at the input and 2 more terminals at the output. But basically transistor is a 3 terminal electronic component only, so that problem can be avoided by taking 1 terminal is common for the remaining 2. In such a case, we can assume or we can treat the transistor as a 4 terminal component, and so that we are assuming the transistor in the 2-port network by taking the 1 terminal is common for the input and output, so that that will be converted into the 4 terminal component, or that will be assumed in the 2-port network. For the 2-port application, one of the BJT terminals need to be made common between the input and output. Among the 3 terminals, 1 terminal can be made common, so that it can have the 3 possible configuration. If the base is common for the emitter and collector, that configuration is named as common base configuration. In short, we can call it as CB configuration, and it is also called as grounded base configuration. That means what? Whichever terminal we will take that as common for the remaining 2 terminal, it must be connected to the ground, so that it is named as grounded base configuration. Common emitter configuration means emitter must be common for the base and the collector, and it must be connected to the ground, so that it is named as grounded emitter configuration, and it is also named as C configuration. Similar to the common base and common emitter and common collector, we will be taking the collector as a common, and it is made as common for the base and the emitter, so that it is named as CC configuration. In short, we can call it CC configuration or grounded collector configuration. These are the possible configurations from the BJT. Next, I am going to talk about the common base configuration. We know that it can be called, in short, it is CB configuration. That means what? This is emitter and it is base, and this is emitter and it is collector, and the base is made as common for the emitter and collector, and it is connected to the ground, so that it is also named as grounded base configuration. It is also named as grounded base configuration, so that now this is base is ground. By making the base is ground, it is divided into the 2 sub-circuit. One is at the left hand side, another is at the right hand side. Left hand side we can call it is a input circuit, the right hand side we can call it is the output circuit. So that we know that input circuit must be connected in forward bias, output circuit must be connected is in a reverse bias. As the basic properties of the BJT, emitter junction must be connected in forward bias and the collector junction must be connected in reverse bias. That means what? This is the emitter junction and it is the collector junction. Emitter junction must be connected in forward bias, means this is arrow head is towards emitter, so that it is called NPN transistor. This is N, this is P, and this is N. NPN transistor. So that emitter is with the N, emitter is with the N, so that N is connected to the negative, and the base is with the P-type semiconductor. P is connected with the positive, so that negative to N-type semiconductor and P-type semiconductor to the positive, so that it is called as forward bias, and output must be connected in reverse bias. That means what? Collector is N-type, so that N must be connected to the positive terminal of the battery, and whereas P must be connected to the negative terminal of the battery, so that it is named as it is VCB. That means what? It is a potential difference. It is a potential difference between the emitter and base, so that we can call it is VEB. Always second suffix defines the type of the configuration. Here the type of the configuration is what? It is a common base configuration, so that we have written it as VEB. We should not write it is VBE, because second suffix defines the type of the configuration, and here VCB is nothing but it is a potential difference between the collector and base, so that we can call it is VCB. We should not call it as VBC, so that here we are having the base is common between the input and output. Input is nothing but emitter terminal and output is nothing but collector terminal. Input voltage is what? Input voltage is VEB, input current is IE, and the output voltage is about VCB, output current is IC. In such a way, you have to describe input characteristic. Generally, we have to remember the definition of the input characteristics. Input characteristics nothing but it is a relation between the input voltage and input current by keeping the output voltage constant. You have to remember this definition of the input characteristics. Input characteristics, it will provide a relation between the input quantities only. Input side, what are the quantities we have? One voltage and one current we have. Input side we have the one voltage and one current. So that input characteristics describes the relation between the input voltage and input current. It describes the relation between input voltage and input current by keeping the output voltage is constant. That means what? From the input characteristics, what we wanted to know? We wanted to know the effect of output voltage on the input side. By weighing the output voltage, we wanted to study what is the effect in the input side. Input side, obviously we are having that one voltage and one current. That voltage is VEB and that current is IE. So that input characteristics nothing but it is a plot between input voltage and input current. It is a plot between input voltage and input current by keeping the output voltage is constant. That means what? Output voltage, by keeping the output voltage is constant, we are going to determine the relation between the input voltage and input current. That means what? If the output voltage is this output voltage is 0, that means what? This is a base is p-type material and the emitter is n-type material. That means it is simply acting as a PN and it is a diode, PN junction diode. It is connected in forward bias, so that when the PN junction diode connected in the forward bias, up to the cut-in voltage there is no current. Whenever it reaches the cut-in voltage, it starts current conduction, and that point of voltage onwards, as you increase the voltage and the current is also increases, so that this point is named as cut-in voltage. And the definition of the cut-in voltage is very important. Cut-in voltage is a voltage at which the diode starts current conduction, that is called cut-in voltage. For a silicon PN junction diode, the cut-in voltage is about the 0.6 volts. For the germanium PN junction diode, the cut-in voltage is about 0.3 volts. So that here we are having the input characteristics, as I said just now. Input characteristics, it is a relation between the input voltage and input current by keeping the output voltage constant. From the input characteristics, we can get the effect of output voltage on the input side, so that it is a plot between input current and input voltage. Input current is IE and input voltage is VEB for various values of VCB. That means what? Whenever VCB is 0, whenever output voltage is VCB is nothing but output voltage. Whenever output voltage is 0, that means what? There is no effect of VCB on the input side, so that it simply acts as a PN junction diode. It is connected in forward bias, so that at the 0.6 volts we can get the current, at the 0.6 volts we can get the current, that is what? At the VCB is equals to 0 volts. Then next case is that as the VCB increases to 10 volts, so that means what? Earlier this VCB is 0, now this VCB is 10 volts. 10 volts is nothing but it is a VCB. VCB is nothing but it is a reverse bias voltage. As the reverse bias voltage increases, that means what? Here the voltage across, that means what? Depletion layer across the emitter collector base junction is also increases. If the collector base junction increases, that pushes the charge carriers in the base towards the emitter side, so that charge carriers of base are going to push the depletion layer across the emitter junction, so that which results the decreasing of the width of the barrier potential as the emitter base junction, so that as the width of the depletion layer increases at the emitter base junction, it can conduct the same amount of current with the lower applied voltages, so that Earlier we have the current at the 0.6, now you can get the current, same current with the less than 0.6 volts only. Likewise you can go with the analysis. Again, if I increase the VCB to 20 volts, again the curve shift left side. That means what? It can conduct the even less voltage of the second case also. Likewise you can go with the analysis of the input characteristic. From the input characteristics we can calculate the two parameters. One is input voltage. Input voltage is nothing but it is a voltage, it is a ratio between the input voltage and the input current. So that we are going with the approximate value, that is Ri, that is AC resistance. It is a AC resistance, and this is named as dynamic resistance, change in input voltage by change in current. So that input voltage, I took the two input voltages, VEB2 and VEB1, and the difference between this one is VEB1 minus VEB2, and here these two will define the corresponding currents here. So that is IF1 and IF2. So that R1 is a dynamic resistance, it is a change, it is a ratio between change in voltage to the change in current. So that I can have Ri is equals to change in voltage by the change in current. That will be the input resistance. Next thing we can define, that is voltage amplification factor. Voltage amplification, generally voltage amplification is also named as voltage gain. Voltage gain is nothing but it is the output voltage by the input voltage. We have the two voltages. Input voltage is the VEB, output voltage is VCB. So that the voltage gain is nothing but output voltage by input voltage. Output voltage is VCB and the input voltage is VEB. So that that amplification factor is denoted with the AV. AV is equals to change in VCB by change in VEB, where the I is constant. Likewise you can have the two parameters from the input characteristics, input resistance as well as voltage amplification factor or the voltage gain you can calculate. Then we have to move towards the next characteristic, that is output characteristics. Output characteristics, nothing but it is a relation between the output voltage to the output current by keeping the input current is constant. As we know that the BJT is a current controlled device, that means what? Output is completely controlled by the input current. So that it is a plot between output voltage, that is VCB, and output current, that is IE, by keeping the input current is constant, input current is IE. So that as IE is 0, then output current is also 0, because IE is approximately equals to 0. If IE is 2 milliamps, so that IC is also 2 milliamps. If IE is 4 milliamps, IC is also 4 milliamps. IE is 6 milliamps, IC is also 6 milliamps, because IC is approximately equals to IE, such that you can go with the output characteristics. You have to go with the definition, proper definition of the output characteristics. Output characteristics is nothing but it is a relation between the output voltage and output current by keeping the input current is constant. From the output characteristics we can identify the three regions. So first one is a cutoff region, next one is a saturation region, next one is a active region. Active region is nothing but when the emitter junction is forward bias and the collector junction is reverse bias, that is named as active region. When the emitter junction and the collector junction both are reverse bias, that is called cutoff region. When the emitter junction and the collector junction both are in forward bias, that is named as saturation region. And from the output characteristics we can calculate the two parameters. One is these are the region of operation. Active region means emitter junction is forward bias, collector junction is reverse bias. The IC is positive, VCB is also positive. IC increases with the IE increases. Cutoff region means what? Both are reverse bias. IE is 0, IC is also 0, then ICPO is also 0. So this is saturation. Saturation means what? Both are in forward bias, that is called saturation. From the output characteristics we can calculate the output resistance and the current amplification factor. Whereas from the input characteristics we have studied the input resistance and the voltage amplification factor. Here from the input side we have calculated what? Input resistance and voltage amplification factor. From the output side what we are calculating? Output resistance and the current amplification factor. Output resistance is nothing but it is a ratio between the output voltage by output current, that is what? RO is equals to change in VCB by change in IC with IE is constant. Current amplification is nothing but current gain only. Just now we discussed that is alpha DC. Now here the amplification factor is alpha AC. Alpha AC is nothing but output current by input current. Change in IC by change in IE. That will be, it is the current amplification factor. So that from any configuration we can calculate the 4 parameters. From the input side 2 and from the output side 2 more. From the input side we can calculate the input resistance and the amplification factor, whereas from the output side we can calculate the output resistance and the current amplification factor. And next one we are moving with the another configuration that is called common emitter configuration. If you are good at the common base configuration, common emitter also same, that is one emitter is common and it is grounded. Base acts as the input and collector acts as the output, so that you have to identify all the voltages and current. Input characteristics, it is a relation between input voltage and input current by keeping the output voltages constant. We know that. And output characteristics means the relation between output voltage and output current by keeping the input current is constant. We studied active region. We know active region emitter base junction is forward bias, collector base junction is reverse bias. Here both are in reverse bias. Here both are in forward bias. And all these things we have discussed, and these parameters we have studied in the common base, very similar. And this is the experimental setup for the determining CE characteristics and the transistor biasing. We are going to study that transistor biasing in coming classes, students. Thank you. And my request is to all my students, try to write the notes of each and every video, such that if you find any doubts you can call me. I am here to help in every aspect and I am going to clarify your doubts. Thank you, student. Thank you so much.